O professor Alan é professor hoje da Washington University em St. Louis, ele é professor na área de genética e de biologia evolutiva, e agora também está com um escritório mexendo com a área da genômica.
What I'm going to talk about today is evolution in coronary artery disease, which may seem at first a very strange joining of two topics that seemingly have nothing to do with one another. Now, coronary artery disease is the single most common cause of death in the industrialized Western nations. The coronary arteries are the arteries that feed basically the muscle of your heart. It delivers oxygen to it. And when you get these blockages, these partial blockages, sometimes they can become complete, particularly if you have any kind of clotting reaction formed around this plaque. It can block the flow of blood through that coronary artery. In 20% of the cases, the first symptom is you drop dead. So there's been a lot of effort over the years of trying to find predictive factors, and among them are genes. And that's where evolution comes in, because evolution is a genetic process. Evolution is really defined by how genes change over time, the types of genes and their frequencies, how they move through space and time in populations. And it turns out humans have a thrifty genotype for cholesterol. Why would we evolve a thrifty genotype for cholesterol? I mean, humans in general have it, some humans more thrifty than others. And the reason is we got big brains. The ApoE4 allele causes a significant increase in risk for coronary artery disease. Okay? When we published this, the reporter said our group had found the killer gene. That was their phrase, not mine. And ApoE only explains about 5% of the cholesterol level. A lot of the cholesterol is determined by other genes. It's determined by your lifestyle, how much you exercise, what you eat. So we know cholesterol level is strongly influenced by many environmental factors, not just your genes. In fact, most of your cholesterol level is due to lifestyle issues. If you have a good genotype, but you have a lifestyle that has increased your cholesterol level, you are the one who is at most risk for coronary artery disease. The genes are part of it, but they're only part. We always have to put the genotypes into their context, and when we do, we get much more information than we would just by talking about diet alone, or exercise alone, or cholesterol level alone, or genes alone. So instead of treating diseases of individuals, we need to treat individuals with disease. And the best physicians already do that.